Now, what I'd like to do in this next operation, do the turning operation on the outside, but this time I'll be using a new operation called balance roughing. I'll start a new operation in turning called balance roughing. What balance roughing does, it allows you to work with two tools at the same time, turning on the part for the rough cut. This allows for a faster finish on the part itself, and we'll get into more benefits of this as we go along. Now note, the moment I did that, I have now two machine types, two sub-machine types. One, the master sub-machine, and I'll be using the upper turret main spindle, and the slave sub-machine, which will be the lower turret main spindle. Again, I'll use my geometry, using my solid geometry that I used before. And now I'll choose my tool. When I go to tool, I'll choose again the first tool I had before, put it in the right position that I need, and now we have our slave tool. If I go into slave tool and click on select, you'll see that I only have one tool over here. This is the tool that I have in my bottom turret. I'll choose that tool, click on select, and you see it automatically comes with the right position. I don't have to click any position over there. It's done for me automatically. I have my levels, and then I have my technology. And if we take a look at my technology, I have the exact same options that I had in my regular roughing operations, with one main thing that's different. Now we have what we call balanced mode. We have two types of balanced mode, simultaneous and trailing. Let's start off with simultaneous. What exactly is simultaneous? Simultaneous allows you to work with both tools simultaneously at the exact same time. They're both exactly parallel one to the other. Now, the advantages of working with this, and we'll see this as we do our simulation, is that you always have support for thin parts on the other side, and you could also work a lot faster with this type of an operation. Let's go into our rough. We'll use our smooth. We'll have our step down value at 2.5 millimeters. Let's have our distance X in 0.3 and my distance Z at 0.1. We have our strategies. We'll put our strategies at non-descending motion. And then we'll do save and calculate. And let's take a look now at our simulation. Again, we'll use the turning simulation. When I start, you can see we have now both of these tools. And you'll note that both of these tools are at the exact same point at the position. When they do that, you can work a lot faster with the tool. And as I said before also, not only working a lot faster, but if this part was thin, this tool always supports that tool over there and vice versa. So there's always support on the tool, allowing for an exact turn on thin parts without worrying about the part bending or warping in any way. We'll let this simulation finish until the very end, and as you can see, it's cutting down on the part all the way to the bottom, exactly the way we want it, always staying simultaneous one to the other. That support is always there, and you'll see as you machine this part that it will be machined a lot quicker because you were able to use two tools at the same time. As we get now down towards our final steps, you'll see now we'll cut that area over there, and now we'll be finished with our rough balance operation. Now let's go back and make a change in our general tab, and this time we'll choose the other option called trailing. What exactly is trailing? Trailing allows for one tool to work behind the other tool, and at the same time it works on a different diameter. So while one tool is turning one diameter, the slave tool, the second tool, is already turning on a deeper diameter because there's no material left there. So let's, for example, make the distance between each one of those of 5 millimeters. In other words, they're working back to back, trailing each one another by 5 millimeters. Now, the slave tool, as it's trailing this, when it finishes, only then will they both start working again. Let's take a look at the simulation as we do this, and we can see this clearly in our simulation itself. Again, we'll start, and note now that the tools are not in the exact same position. This one is rather back 5 millimeters from this point over here. I'll start my simulation. And you see the tool is working across, and you can see over here already that this is deeper on the next diameter, working on the next diameter. Now this tool did not start until this one got back over here. No, they'll always wait until they both get back. This is now waiting, and it's starting on the next diameter over here itself. And you can always see at these steps over here that it's always working on the next diameter. This one on the outside one, and this one on this next one over here, as shown over there. And this goes all the way down, and it'll always wait until this finishes its step to start working, as shown over here. Now this one is waiting until this gets back, and now we've finished the turning using the balanced roughing of trailing.